In this video, we're going to be talking about section 1.5, part 2. So we're continuing our basic operations on functions, and today we're going to specifically review the composition of functions. If you recall, composition of functions is essentially, sort of informally, when you take one function and insert it into the other function. The notation that you'll see is the F little circle G. It is not a big old O. It is not the word fog. This is F little circle G. It is not multiplication. This is a notation that is not very informative, right? It doesn't really tell you what to do unless you know what to do. But what it means is this notation. And this is the notation I prefer, and that's the one I will use if I'm writing it for myself, because it is informative, right? It is telling you to plug in and insert the function g of x into the function f. Much like if you had a function and you said f of 2, that would tell you to plug in 2. F of 3 tells you to plug in 3. We did this earlier. F of a would mean plug in a. So f of g of x is telling you, go find this function g of x, and just like you did with the 2 or the 3 or the a or the x plus h, or whatever else we've done this year, we're going to replace the x with whatever that is. So it's pretty simple as long as you understand the notation and you don't screw it up. So here we go. Let's just power through some examples. Given these two functions, let's go ahead and evaluate. Looks like I've got 4 problems there. So f of g of x simply means this, which means take function f, and here's my advice to you. Take the function wherever there is an x in your function you're putting things into, put a parenthesis. So I'm going to change this to say x plus 2, but I'm going to change it to a parenthesis plus 2. And then all I have to do is go find the other function and plug it into the parentheses. Now, in this case, my parentheses are worthless, but almost every time you're going to need parentheses there because there'll be something squared or a multiply or a subtract. So good habit to stick in, even though in this case it didn't really matter. So ignoring the parentheses mentally, I can see I can add the 4 and the 2. So this just becomes negative x squared plus 2. And if I want to do g of f of x, g little circle, that means this. So I go find function g, and I'm going to write it down. 4 minus parenthesis squared. And inside that, I'm going to put x plus 2. I'm going to do a little simplifying. Notice I have my binomial squared. Don't screw it up. Also, don't forget there's a subtraction. So x squared plus 2xh plus h squared. Oops, sorry, my brain went well into something else. Let's try that again. X squared plus, multiply them together, I get 2x and double, 4x, and then square, and I get 4. Distribute the negative. Looks like my 4's are going to cancel, and I'm left with negative x squared minus 4x. Okay. Now, the next questions are saying, now let's do evaluation. Okay. So f of g of 2. That can mean, just like it did in the last section, it can mean find your new problem, right? Find your new formula, by doing your composition like we just did. And now it's saying essentially this: find f of g of 2. In other words, we built our new function. It's going to simply be, now we plug in 2. So negative is on the outside of the squared. And so I end up getting negative 4 plus 2 is negative 2. Okay, but I want us to look at this another way. Had we not built the function, I want you to think about what this is saying. So here we have a function f of x, and we have a function g of x. a composition function, if I'm doing f of g of x, then what that's saying is, and it's actually going to be a little backwards from how I drew it, this is saying, like, what is the innermost function? Notice what this 2 is attached to. This 2 is actually going into g based on how we wrote it here. So what we're doing is we're actually plugging in a 2 here. Like 2 goes in, and then it's going to come out and become the input of the function f. So g of 2 comes out and becomes now the input f of what? G of 2. And then whatever comes out of that is our answer. But 2 goes into G, that's the domain of G, and then the range of G is whatever the output is, and then that output becomes the input of F. Okay, so comes into here, does G of 2, and spits it out. So let's see that in action. So let's find out what G of 2 is. So G of 2, I plug in 2, and I get 2 squared, which is 4. I get 4 minus 4. So G of 2 is 0. And so notice what I've written right here. F of. Well, we now know what G of 2 is. So when I say F of G of 2, that's really just now saying F of 0. So now 0 is the input on function F, which becomes 0 plus 2, which, oopsie, I've made a mistake someplace because that should just be 2. Okay, going to be a weird edit here, simply because, man, this is legit like my 7th video of the morning, and I'm getting a little bit punchy. So I couldn't figure out why it didn't give me the same answer, and I'm looking back, and probably if you were watching this video screaming at me the whole time, you'll see I made a silly error. So 4 plus 2 right here, this should not have been a 2. This should have been a plus 6. And so then 2 squared is 4, negative 4 plus 6 is positive 2 when we did this one. All right, so then I was correct what I said. When I plug in 2 for G, it spits out a 0, and then when the 0 comes in here, it becomes 0 plus 2 and I get 2. So plugged in a 2, a 0 came out, making it the input, and then the final answer here, coincidentally, seems to be the same number we plugged in. All right, sorry. Weird edit. Let's keep going. Hopefully I didn't make a mistake over here. So then G of F of negative 1. So one thing I could do, I could just build a new function and not worry about it, which is what I've done here. And now I can just do G of F of negative 1 by plugging in here. And getting, let's see, positive 1, but now it's back to negative 1. So negative 1, there's a negative 1 needs to go in here too. So that becomes plus 4. So unless I'm still making errors, we should get a 3. All right, but what's another way of approaching this question? Another way of approaching this question is it's saying, hey, in this case, f of negative 1. So I'm saying find out what you get when you plug in negative 1. And then that's going to come spit out and become the input for G. And then we'll see what we get coming out. So I could answer this question also by doing just what it says here, f of negative 1, which is negative 1 plus 2 is 1. So I plug in a negative 1, and a 1 comes out, which means that is now going to be the input of G. So then G of 1 is 4 minus 1 squared. 4 minus 1 is 3. And I get the same answer. All right. Let's keep rolling. Example number 2. F of G of X. Find f of G of X. State the domain of the function, of each function and the composition. All right. So part A. Let's do the domain of each one first. Obviously, the domain is all real numbers, and the domain is all real numbers. Okay, so got that part down. Let's now build and find the new function. So f of g of x is equal to, take the function f, parentheses, squared. Plug in x plus 1. Since there's nothing else really going on in this one, we're not going to like divide or add anything else. I think I'll just leave it as x plus 1 squared. Okay. And so we said the domain was all real numbers here. The domain is all real numbers here. And the function we've built now we'll evaluate separately and see that it's all real numbers. Okay. So all three, the domain would be all real numbers. Okay. And now let's do f of g of x over here. So f of g of x, we're going to take function f. And then inside of the x, I'm going to put x minus 1. And so there is our new function. All right, now let's have a discussion about the domain. If I look at this original function, the domain of that would be all real numbers. Sorry, brain went to somewhere else. All real numbers greater than or equal to 0. So the domain here are all the x's. I'm just going to quickly shorthand it. 0 to infinity. The domain here is everything. Now, the domain of this one, we now will consider separately. It is the square root of x minus 1. And this is saying now that 0, which was okay a minute ago, right, is no longer okay because 0 makes a negative in here. So the domain of my new function becomes the square. Oh man, I should probably stop making videos. My domain here should be all of the x's. I'm going to shorthand it again, from 1 to infinity. All right. So the one thing to consider is the range coming out of function f. Oh, function g, I mean. The range coming out of function g becomes the domain of f. So if we had limited what we were plugging in, then we just kind of have to think this through a little bit sometimes. In this case, it's pretty straightforward because the domain got more restrictive as we went. And so, I think we're good. Let's see if that gets a little bit weirder on this next problem. All right. Given f of x and g of x, find the function f of g of x. What's its domain? Graph it, the whole thing. So let's find f of g of x. Let's do what it says. Which is going to be 1 over x, so parentheses squared minus 4. I'm going to put in the square root of x. Simplify, I get 1 over square root of x squared is just x, so this becomes x minus 4. So here is where we're going to get ourselves in trouble, because it would appear from our simplified function that we got right here that we do have a domain issue, and that domain issue would simply be at 4 and everything else would be fine. Right? So the ultimate result here is we got a rational function, and it has an asymptote at 4. 1, 2, 3, 4. And then everything else is pretty standard. Asymptote on that axis. If the axis is your asymptote and you draw it reasonably well, then you don't have to do a dotted line over the top of your axis. It'll be understood that that's what you mean. Okay, so So it would appear to be this is the graph, everything's great, walk away 100%. But we have ourselves an issue. And let's see if we can figure out what that issue is. And let's see if me in my tired state can explain it to you. All right, f of g of x. So let's focus on g of x for a minute because g of x is the input, right? So numbers come into x and they come out of x and they go to function f. And make sure you makes that makes sense to you, right? So if I asked you to do f of g of 2, then that's saying find g of 2. So 2 goes into here, get an answer, and then the answer to that becomes the input here. All right, so the reason we have to consider this is because the square root of x has a limited domain. Once I plug it in, this squared kind of makes it seem like who cares, right? And that issue goes away. However, thinking about what we just said, plugging in g of 2 and getting an answer, that happens first. So if I were to plug in -1, I get an imaginary number. And so whatever causes an imaginary number is something I can't use. Even though once it gets in here, that imaginary number gets squared and sort of gets resolved. I still can't consider those negative numbers. So my domain should be all real numbers greater than or equal to 0. So this domain, the only numbers I can plug into this are from 0 to infinity. And the answers to those questions are going to be very limited. What are the answers to those questions going to be? Like the output of 0 of the square root of x from 0 to infinity. When I put those in, I just get this. So what's my range of g of x? The range of g of x is the same. I'm going to get 0 as an answer, and I'm going to get everything bigger. So what does that mean in terms of our graph? That means I'm only plugging numbers between 0 and infinity into here and getting answers. So unless I'm really, really tired, then what I think I should be telling you is this graph should be starting. Actually, I can have the value at 0. Come on, eraser. Thank you. I think the graph should look like this. And I say I think because honestly, like I said, I've been at this for about 6 hours. I'm getting a little tired. To do part B here, it's going to have the same basic issues. So f of g of x, what is the domain? So the input of g is our overall domain. And then it's going to spit out stuff to come to here. So whatever we plug in here is going to really determine what happens next. So I can only use values between -1 and infinity. And so when those -1 to infinity plug in here, I'm going to get answers. And so this should be the domain of the whole function. And I think that's it. So even though I may graph this or create this new function, right? So f of g of x, as I create this new function, I get x squared minus 4. But the square root of x plus 1 goes in here. And then that simplifies out. The square and the square root cancel out. And it looks like I get a nice statement of x plus 1 minus 4. I get the equation x minus 3, which we know has no domain restrictions. And so we might mistakenly say that the composition graph is this linear equation right here. However, we should only be putting in values between -1 and infinity. So I got to get rid of this and get rid of this. And my graph should just be this. And the domain of the function is right here.